Alright, hey guys, I'm going to try to do a couple quick examples of ambiguous case problems for law of sines. Take a second, copy this down. We're giving you that in a triangle we know side little b is 2, side little c is 3, and angle b is 40 degrees. Okay, so what I want to show you real quick, like if we put this on a triangle, alright, and just any old triangle that doesn't necessarily make sense here. Okay, so side B is 2, side C is 3, and angle B is 40 degrees. I'm going to have to do that. Angle B is 40 degrees. Notice that this is side, side, and then angle. When it's side, side, angle, that's when we know it's going to be a possible ambiguous case problem. Okay, so we start off the same way as normal, so I'm going to make my little thing here. A equals, B equals, C equals, and then A equals, B equals, C equals. So I'll fill this in. We got 2 and 3, and then 40 degrees. So I can see right away that I'm going to be using law of sines with B and C. So I'll set up my sine of 40 over 2 equals sine of C over 3. And let's cross multiply and divide here, so that gives me sine of C, my sine of C equals 3 sine 40 over 2. It's hard to write on this. Sine of C is equal to about 0.964. So we are gonna do a little estimating here where I want to figure that out. So if you think about that, this is saying that the sine of some angle is 0.964. Right? Well, remember that's like the y value. All right, is 0.964. And if we were to think about this on the unit circle, I'm going to draw a little picture over here. Here's my unit circle. Well, 0.964 is almost 1, so there's a couple angles where that's going to happen. All right, there's one angle in the first quadrant, and there's an angle in the second quadrant, where the sine value is going to give me, the sine of that angle will give me 0.964. So when we do sine inverse here, so we're going to get C equals the sine inverse of 0.964. Again, make sure your calculator is in degree mode. We get that C equals 74.619 degrees. 74.619 degrees. Okay, well that's my first quadrant angle. So if I want to find the second quadrant angle, this one there, well, that's going to be 180 minus 74.619, because if we think of the angle between the negative x-axis and my second quadrant version, that's going to be the same 74 degrees. So if I do 180 minus the 74, that'll get me the obtuse angle measured from the first positive x-axis. Okay, and when you do that, so 180 minus that, 180 minus 74.619, that's going to equal, where is it, 105.281. 105.281. All right, so what we're looking at here is that are these two possible angles for this triangle. Okay, so C could be, and I'm going to fill in my chart here, 74.619 degrees. But we also have another possibility. It could be 105.281. So I have to make a new chart. A equals, B equals, C equals. All right, big A equals, big B equals, big C equals. So in this one, B and C are still 2 and 3, and angle B is still 40 degrees, but now angle C is going to be 105.281. Okay, so I now have these two possible triangles. Okay. Then I'll do, 180 minus both of those angles to get angle A in both cases. So in the first case, I get angle A is 65.318, and I get, in the second case, I get angle A is 34.719. Okay, so now I have all three angles for both cases, and it's just a matter of using law of sines to find side A for both situations. So take a second to try to figure that out, pause the video, and then I'll put the answer up. Okay, so when you do the math here, so I did it for the left side, sine 40 over 2 equals sine 65.318 over A, cross multiply divide, and we get about 2.827. So that's my side A in the first triangle. When you repeat that process for the second triangle, you get about 1.772. Okay, one thing you can always check to make sure your answer makes sense is that the biggest side goes with the biggest angle, the smallest side with the smallest angle, and the mediumest side with the mediumest angle. Okay, so you can check to make sure that your answers make sense, and in both of these cases they do. All right. Quick hypothetical on this one. When we found our two angles, so we found 74.619 and 105.281. Let's say we plugged in the 105.281 here, and this angle and the one we were given added up to more than 180. Well, then you would know that this other triangle wouldn't work, so we would only have one possible triangle. Okay, I've got one other quick problem here. Let's try this one. Okay, in this one, we're given that A is 5, B is 1, and angle B is 35 degrees. So again, I would recommend always just making a quick triangle sketch to see do I have angle or do I have side-side angle. If I do, then I need to be careful. So little a is 5, little b is 1, and angle B is 35. Looks like I do have side-side angle. Okay, so I'm being on the lookout for ambiguous case here. Okay, so I'm going to go A equals, B equals, C equals. Okay, and when I fill this in, 5, 1, 35. Okay, so set up your law of sines to start to find angle A. Okay, so when you do that, you get sine A over 5 equals sine 35 over 1, cross multiply, and we get sine A equals 5 sine 35. Well, when I do 5 sine 35 on the calculator to get an estimation here, we see that sine A equals about 2.867. 2.867. Well, that should ring alarm bells because sine is never bigger than 1 or smaller than -1. Okay, and in fact, if we did the inverse to try to find it, so sine inverse of 2.867, you'd say, hey, that's a stupid question. Okay, it's out of the domain, so we say undefined. Right. Well, what does this mean? That means this is an impossible triangle. We can't have a triangle where side little b or little a is 5, little b is 1, and angle B is 35 degrees. Okay, what's going to happen is that side of 1 is just never going to be long enough to reach the third side. Okay, so we'd say impossible triangle, and we're done. Okay, so good luck on those law of sine ambiguous case problems, and we'll talk over law of cosines tomorrow. Thanks for watching.